Our mission for this deep dive is to explore a hypothesis that the most common pattern in all of existence,
The normal distribution. The bell curve.
the bell curve,
Yeah.
that it's not the primary reality, that it's actually a defect, a distortion of something much more fundamental.
That's a huge shift. I mean, it completely flips our ontological priority.
It does.
Because in the conventional scientific view, all that variance, the scatter, that is the reality. And then we use math to create abstractions.
The mean, the equation of the line, the standard deviation.
To describe that physical reality.
Exactly. We give all the weight, the ontological weight, to the physical diversity we can measure. We just assume the spread is an authentic feature of existence.
It's the diversity you need for evolution, or it's the inherent randomness of quantum mechanics.
Right. And the thesis we're exploring today, which draws heavily from foundational Indian philosophy, has a specific word for this observed spread. The word is Vikara.
Okay, so if the conventional view is wrong, what's the inverted thesis? If the scatter isn't real, what is?
The inverted thesis is that the underlying mathematical rule, the perfect dimensionless law, the mean that is the only true singular reality.
The signal.
The signal. And the Vikara. Well, the Vikara is the physical world spread, the bell curve that we actually see and measure.
So the physical world is like a noisy channel.
Yeah.
Like a bad radio transmission of that perfect rule.
That is the perfect analogy. The physical world is a noisy channel transmitting a perfect underlying deterministic rule. And the bell curve is, therefore, just the structural pattern of the transmission error.
It's the shape of the noise.
It's the shape of the noise that's introduced by the medium of manifestation itself.
Welcome to the Deep Dive. I'm Satosha.
And I'm Satoshi.
Okay, so let's define these core concepts really clearly for everyone. The perfect rule is the signal. In some frameworks, that's Atman or knowledge.
And the resulting bell curve, that distribution of error, is the noise. That's the Vikara, or in other systems, Maya illusion.
This really gets at that old tension between math and physics, doesn't it?
The eternal tension. Mathematics deals with the perfect one. A perfect circle only exists as an idea, an equation.
You can't draw one. You can't find one in nature.
Never. But physics deals with the imperfect many, scattering particles, measurements that always have error bars, approximations, and we almost always give priority to the messiness of the money.
And we assume those imperfections are intrinsic to the thing we're measuring, not an error in the transmission.
Let's use an example to make this concrete. The oak tree height example really crystallizes the difference.
Okay.
So if you walk into a forest and you measure the heights of, say, 1,000 mature oak trees, you are going to get a bell curve. It's inevitable.
Right, a classic normal distribution. And conventional biology tells us that variation is real. It's genuine biological diversity.
It's the raw material for natural selection.
Yeah.
Some trees are taller, some are shorter, and that distribution is the true state of that ecosystem. That's the standard view.
So how does the Vikara view interpret that exact same bell curve?
It completely flips the meaning of variance, of sigma squared. The Vikara view would say that the form of the oak tree, the ideal perfected blueprint, the signal, is a singular invariant idea.
A perfect oak tree concept.
Yes, a deterministic blueprint held within cosmic intelligence. And the distribution we observe in the forest is not a map of diversity. It's a map of the material world's failure to perfectly instantiate that form.
Wait, hold on. So the differences between the trees aren't a sign of genetic strength or variety, but they're mapping mistakes.
They are mapping the defects of the substrate, the specific imperfections. This tree over here has poor soil. That one got hit by wind. Another one suffered a transcription error in its genetic code.
All the little things that go wrong.
All the little things. Those are the defects, the Vikara, introduced by the material substrate, which is called Prakriti. And so the standard deviation, sigma, and the variance, sigma squared, become the literal measure of this failure. It's a scale of the noise.
That's a profound shift. So if variance is a measure of defect, what does that do to the idea of genetic diversity in evolution? Is natural selection just, what? Optimizing against a mistake? Trying to find the closest copy of the ideal form?
That is exactly the implication. We're redefining diversity from being this essential ontological necessity to being, well, an epistemic tragedy.
A tragedy.
Evolution, in this new context, becomes the system's ongoing attempt to overcome the Vikara of the environment, all that noise, to express the intended cosmic order the rita of the form.
So the fittest tree is just the one that best minimizes the effects of all those physical defects. It's the one that gets closest to that perfect singular mean height.
It's the one with the lowest error term.
This has to completely transform the role of probability theory itself then.
Yeah.
It's not just a descriptive tool anymore.
Absolutely not. It's transformed from a descriptive science of chance, telling us what the scatter looks like, into a normative tool of epistemic filtration.
Epistemic filtration, meaning a tool for filtering knowledge.
It becomes the methodology that the human intellect uses to rigorously filter out all the observed physical defects, all that noise, in order to get back to that perfect underlying deterministic rule, the signal.
So we're using mathematics to systematically erase the physical world's mistakes to find the truth that's hidden underneath.
What's so fascinating here is that we're talking about modern statistical theory.
Right.
But this entire architecture of reality, signal, noise, and the structural relationship between them, it's not new. It's deeply rooted in ancient frameworks like Samkhya, which is one of the oldest, if not the oldest, system of Indian philosophy.
This perspective has been around for thousands of years.
And we can trace this exact ontological architecture back to Samkhya's radical dualism. It defines two eternal, independent principles, Purusha and Prakriti.
And they map onto signal and screen, reality and manifestation.
Astonishingly well. It's almost a one-to-one mapping.
Okay, let's unpack the signal first. Tell us about Purusha.
So Purusha is pure consciousness. It's the seer, the witness, the sakshi. You can think of it as a perfect, unwavering light source.
The observer.
The ideal observer. But crucially, Purusha is defined as nirvikara.
Nirvikara, so no vikara, no defect.
Exactly. This is the key philosophical point. Nirvikara means without modification, without activity, without attributes, and absolutely without variance. It is the transcendental, deterministic constant. It is the perfect, invariant mathematical law.
So Purusha is like the pure mathematical code, perfect and silent, waiting for a system to express it.
And that system, the one that generates the world and therefore generates all the noise, is Prakriti.
The screen.
Prakriti is the screen. It's the active creative force. It's the source of all energy, all mind, all matter. It's incredibly dynamic, but it's blind. It's blind to the perfect code that it's trying to display.
And in its original state, its primordial state, it's just pure potential, right?
That's right. In its primordial state, Mula Prakriti, before the universe manifests, its three constitutive qualities, they're called the Gunas, are in perfect equilibrium.
And that state is called avyakta, unmanifest.
Unmanifest. And think about what that means statistically. It means zero noise, zero distribution, just pure potential energy in perfect balance.
And the moment that balance is disturbed,
the universe begins, the distribution appears. And this is where the Gunas map perfectly onto the statistical moments of the bell curve. This is the absolute centerpiece of this whole synthesis.
So Prakriti is made of these three gunas, these fundamental forces. Let's detail that relationship. Start with the center of the distribution, the most important part.
That is Sattva. Sattva is the quality of clarity, of light, goodness, harmony, intelligence. It's the force that reveals truth.
And statistically?
Statistically, Sattva corresponds precisely to the mean, to mu. It is the central tendency. It's the point of highest probability density where the essence, the truth of the underlying law resides. It's the most stable, most economical, least entropic position on the entire curve.
Okay, so Sattva is the central point of truth. Next is Rajas. This sounds like the engine of the universe.
It is. Rajas is activity, passion, turbulence, motion. It's the energy that disturbs the harmony of Sattva. It's the projecting force, the movement of data points away from the mean.
So Rajas is the variance.
Rajas corresponds exactly to variance, to sigma squared. It is the force that actively pushes particles, individuals, measurements, whatever you're looking at, away from the perfect rule. It creates the dispersion. It creates the entire width of the bell curve.
So when a statistician is measuring high variance in a data set, they are literally measuring the kinetic force of Rajas at work in that system.
That is precisely the claim. Rajas is the statistical force of scattering. If a system had zero Rajas, all the data points would just cluster deterministically right at the mean.
There'd be a single point.
A singularity. The very existence of Rajas guarantees that the bell curve is wider than a single point.
Okay, now I need to reconcile the last guna, Tamas. I always thought of Tamas as inertia, darkness, heaviness. How does that fit in? I would have thought the tails of a distribution were caused by extreme activity, by Rajas.
That's a really critical distinction, and it's subtle. Tamas is inertia, heaviness, resistance, occlusion. it resists change, and crucially, it resists the return to equilibrium.
Oh, okay.
So while Rajas provides the initial outward push from the center, Tamas provides the structural stickiness that prevents everything from instantly snapping back. Statistically, Tamas corresponds to the noise floor or the heavy tails of the distribution.
So Tamas isn't the explosion outward. It's the persistence of that extreme state. It's what keeps the outliers out there.
Exactly. It is the deep entropy in the system that ensures that even the most extreme deviations, the 3 or 4 standard deviation events, they persist for a measurable amount of time. It prevents the system from instantly returning to the perfect Sattvic mean. It's the obscuring force that makes those high variance outliers so difficult to filter out.
This is incredible. It means the very mathematical structure of the Gaussian curve is, according to this, baked into the fundamental forces of matter as described by Samkhya.
The existence of the bell curve is the physical manifestation of the Gunas interacting. It is the statistical portrait of material existence, and that portrait is Vikara.
And the word itself, Vikara, you said it comes from V and Kri.
Yes, V, meaning variation or deviation, and Kri, meaning to make. So to make a deviation. And while it can just mean transformation in the metaphysical context, especially when you're talking about the soul's liberation, moksha, it is unambiguously defined as defect, distortion, or estrangement from the original perfection of Purusha.
And the physical world, the one that we're measuring with all our instruments, isn't just a single defect, is it? It's a cascade.
It's the Vikara of a Vikara of a Vikara. The Samkhya model of evolution proceeds through layers of increasing density and increasing noise. The first modification, the one closest to the pure light of Purusha, is Mahat, or Buddhi, intellect.
Which is mostly sattvic, mostly clear.
Predominantly sattvic. It has the most information, the least noise, but then the noise starts layering in as that pure intelligence individualizes.
Right.
Mahat modifies into ahamkara, the ego, which introduces the fundamental separation of I from the whole. Then you descend through the subtle elements, the senses, the mind, and finally...
the physical world.
Finally, the Mahabhutas, the gross elements, earth, water, fire, air, and space.
And the Mahabhutas are the end of the chain. They're the things we can touch and measure.
They are the furthest removed from the source, from Purusha. And therefore, they are in the most noisy state of existence. When we measure the speed of a particle or the height of an oak tree, we are measuring the debris of this cascading modification.
We're measuring the residual energy of rajas and the sticky inertia of tamas.
The normal distribution is the mathematical structure of the scattering of that original unitary intelligence into the multiplicity of all these material forms.
In this philosophical framework, it goes beyond just Samkhya, right? I'm thinking of Advaita Vedanta, the non-dualistic school. They tackle the same problem, but they use the concept of Maya, the world, as illusion.
Absolutely. For Advaita, there is only one reality, Brahman. That's our perfect, singular signal. The world we see is Maya, which literally means that which is not.
And Maya has these two powers that generate the bell curve, so to speak.
It has two fundamental operational powers. The first is avarana, the power of veiling. This is what covers the signal. It obscures the truth of Brahman.
And the second one is what creates the spread.
The second, and the one that's critical for our discussion, is vikshepa, the power of projection. Vikshepa is the force that makes the infinite appear finite. It makes the one appear as the many. It scatters the unitary truth into a world of diverse, separate phenomena.
So the normal distribution is the signature of Vikshepa. It is the literal projection of multiplicity onto an underlying unity.
Exactly. And to accept the distribution itself as the ultimate reality is to fall victim to the fundamental error of avidya, or ignorance. The bell curve is a precise map of the illusion, but it is still the illusion.
Which means the highest goal of spiritual knowledge, jnana, is structurally identical to the highest goal of statistical analysis.
Which is filtering out the noise.
Right.
The path to knowledge in Vedanta is the systematic negation of the phenomenal world. It's summarized in the famous instruction, neti, not this, not this.
You reject the data points.
You reject the distribution. You reject the Vikara to find the singular unmanifest essence, Brahman, that lies beneath all that scatter. The statistical pursuit of the perfect variance-free mean is the mathematical mirror of the spiritual negation of Maya.
This philosophical structure gives immense weight to the idea that randomness isn't fundamental, it's an illusion. So let's turn to physics now and see if the empirical world actually supports this inversion. And we have to start with the ultimate symbol of chance.
The coin toss.
The coin toss. We all assume p heads equals 0.5 because it's the very definition of random.
And this is where the work of Percy Diaconis is so incredibly compelling.
The mathematician and
900.
former magician, right?
A former stage magician, yes. And his research proved that coin tossing is not fundamentally random chance. It is deterministic physics. It's just Newton's laws. It is a simple trajectory problem.
But that feels so counterintuitive. We've all flipped coins thousands of times and seen it come out 50-50 in the long run.
The key insight is that our perception of randomness is rooted entirely in our ignorance of the initial conditions. Diaconis and his colleagues showed that if you know the exact initial conditions, the upward velocity, the angular velocity, the air resistance, the outcome is completely predictable.
There's no probability.
There is only calculation.
And they proved this experimentally with that specialized coin-tossing machine that was designed to show the signal without the noise.
It's a fantastic demonstration. They built a mechanical device that could replicate the exact same initial conditions over and over, completely eliminating the Vikara, the clumsiness, introduced by a human hand.
And what happened?
When they did this, they could make the coin land on heads 100% of the time, every single time. The result was not a distribution, it wasn't a bell curve, it was a single deterministic point. The physical defect was removed, and the rule was instantly revealed.
And even when humans do it, just normally, the research showed the process isn't truly fair, is it?
Not at all. Even in human hands, there's a same-side bias of about 51%.
51%. Why?
Because the coin isn't just flipping end over end, it's also spinning, like a little gyroscope. And due to precession, it spends slightly more time in the air with the side that started up facing up.
So it has a memory.
Physics dictates the bias. The laws of motion are the true signal.
Okay, so if the coin itself is deterministic, why does the bell curve of outcomes appear when we throw it? Why do we settle for a 50-50 probability model?
This is the absolute crux of the Vikara thesis. The distribution, the randomness we perceive, arises entirely from the defect of the human operator. Diaconis himself summed it up famously. He said, in a sense, it is not the coin's randomness that is at issue, but our own clumsiness.
Our own clumsiness, so the imperfections, the noise, it's all generated by the thrower, not by the coin.
Exactly. The bell curve we measure describes the variations in the physical agent's ability to execute a deterministic law. It's the microscopic tremors in our muscle fibers, the slightly inconsistent release timing, the tiny air currents in the room.
These are the Vikaras.
These are the Vikaras that prevent the perfect, predictable result. The distribution literally describes the limitations of the thrower, not the freedom of the coin.
This challenges our entire interpretation of what randomness even is. It shifts it from being an ontological property of the universe, a fundamental feature of reality,
to an epistemological measure of our own limitations.
of our ignorance.
And this exact transition was argued for so rigorously by the information theorist E.T. Jaynes.
With his concept of the mind projection fallacy.
The mind projection fallacy. Jaynes argued that probability is fundamentally a measure of our information, or, conversely, our ignorance. It is not a physical property of the external world.
So when we see a distribution, we are often just projecting our own state of uncertainty onto the universe. We're confusing our lack of knowledge with inherent chaos.
That is the fallacy. We confuse our own lack of omniscience, our avidya, with a feature of external reality. If we had the perfect knowledge of Purusha, the ability to measure every single variable involved with perfect precision, the probability distribution would collapse.
Into a single point.
Into a single point. We would see a trajectory, we would see certain outcome, not a fuzzy bell curve. Probability, in this view, is just a tool we invented to help us cope with the material world's persistent noise.
Let's just summarize that radical shift, because it really crystallizes this whole inversion.
Okay, think of the comparison. In the standard view, the coin is a random number generator.
Right.
In the inverted view, it's a deterministic physical object, a system defined by perfect laws, by Raita. The distribution we see is not the truth of the toss, it's the map of human clumsiness. It's the Vikara.
And most critically, the 50-50 probability isn't an inherent physical property.
It is simply the measure of our ignorance, our avidya of the coin's true initial conditions.
Here's where it gets really interesting for me, because if the world is noise, then statistics isn't just about description anymore, it's mandatory error correction.
It is.
And if we accept that, then the entire scientific method starts to look just like a spiritual practice. Both are systematic processes designed to filter out the defect and recover the perfect signal.
And the mathematical architecture for this exact filtration process already exists. It's called signal detection theory, or SDT.
SDT, this came out of engineering, right? Like telling the difference between a real airplane on a radar and just a cloud.
Exactly. Distinguishing a real signal from background static or noise. Every single observation is modeled with a simple equation. X equals S plus N. The observation you make is the true signal plus the noise.
So in this context, the whole exercise of science becomes this continuous diagnostic test.
Hmm.
Is this thing I'm measuring real? Or is it a defect? Is it signal or is it noise?
Which is precisely the philosophical task defined by the term viveka in Indian philosophy.
Discriminate or discernment?
Viveka is considered the highest intellectual faculty. It's the ability to distinguish the real, sat, from the unreal, sat. The self, Atman, from the non-self, Anaman. And SDT gives us the mathematical tools to actually quantify that spiritual ability.
So how does that work? How do you measure clarity?
The key parameter in SDT is the sensitivity index, called D prime, and it measures the distance between the mean of the noise distribution and the mean of the signal plus noise distribution. It is the quantifiable measure of how clearly the truth is separated from the falsehood.
So if your sensitivity, your dollars is low.
If dollars is low, the two distributions, noise and signal plus noise, they overlap almost completely. You are in a state of deep tamas, of ignorance. The world is just a confusing, random blur where you're constantly mistaking the signal for the noise and vice versa.
But as you increase dollars, as your perception gets clearer, the distribution's separate.
As dull increases, the mean of the signal plus noise clearly pulls away from the mean of the noise alone. You can clearly discern the rule standing apart from the defect. This intellectual clarity corresponds to the state of Sattva. A statistician trying to maximize dollars in their experiment is structurally performing viveka.
This makes the scientists running a regression analysis look like a hidden yogi achieving neti with their data set.
It's the same process.
Let's look closer at regression, because that really embodies this philosophical rejection of the physical world.
Okay, so when a scientist fits a line, which represents the underlying deterministic law, to a scatter of physical data points, the messy reality, they define the distance between each data point and that perfect line as the residual.
Or the error. And the goal is always to minimize that error. We use the method of least squares, minimizing the sum of the squared errors.
Now stop and consider the profound ontological implication of what you're doing when you minimize the squared errors. The scientist is actively, mathematically discarding the specific location of the physical data points, the Vikara.
You're saying their actual position doesn't matter.
It's treated as an error to be eliminated. You discard that physical reality in order to affirm the mathematical abstraction, the equation of the line, as the objective truth, the law.
The physical manifestation is disposable, but the abstraction is held up as the real invariant truth.
Science is, therefore, the systematic mathematical rejection of physical variation in favor of affirming mathematical unity. The data points are noise, the line is the signal. It is a practical, applied embodiment of the neti principle. Not this physical point, but the rule it approximates.
It's the statistical embodiment of the entire Samkhya framework. The techniques we use to establish scientific certainty are all designed to minimize the impact of Prakriti's modification.
To reveal the constancy of Purusha.
And this whole methodology for dealing with doubt and uncertainty, it was recognized even in ancient Indian logic, wasn't it?
Oh, absolutely. In the Nyaya school of logic, the entire quest for knowledge centered around resolving samkhya, or doubt.
And doubt arises when you can't tell the signal from the noise.
Exactly. When, like the overlapping distributions in SDT, you see conflicting properties in an object, you see the blip on the screen, but you're not sure if it's the real signal or just a Tamasic artifact, just noise.
So how did they manage that without calculators and statistics?
They used a tool called Tarka hypothetical logical argument. Tarka functions like a pre-statistical error correction method. It's a form of reductio ad absurdum that you use to systematically eliminate all the incorrect hypotheses until only the most robust explanation, the one closest to the mean, is left standing.
It's a logical way to minimize the variance in your thinking.
Precisely. And there's a direct modern link, too, with the Jain school of thought and their probabilistic logic.
The Jains had this idea of Shyadvada, the doctrine of maybe.
Yes, or conditional predication. This doctrine, which is encapsulated in 7 different forms of assertion, was an explicit acknowledgement that in the realm of Vikara, in the manifold, messy, manifest reality, which they called Anakantavada absolute, unqualified certainty is often impossible for the human intellect.
So they weren't denying that truth exists. They were just saying that our statement of the truth is always contingent on our perspective, which is clouded by noise.
They understood that all our knowledge is relative to the observer's limited state of information, our avidya, and this understanding was so profound that P.C. Mahalanobis,
The founder of the Indian Statistical Institute, a giant in the field.
he explicitly linked Jain logic to the necessity of modern statistical thinking. He argued that the Jains, centuries ago, grasped the absolute necessity of probabilistic thinking to navigate a world that is defined by imperfect information.
Okay, let's shift back to the signal itself. If we successfully filter out all this physical noise, all this Vikara, what is the nature of the rule that's left? What is the reality that's hiding beneath all the scatter?
Modern physics is increasingly suggesting that the substrate that remains is purely mathematical or informational. And this brings us right to the philosophical movement of information realism.
And the famous quote here, the one everyone knows, is from the physicist John Archibald Wheeler.
It from bit.
It from bit.
Wheeler's radical hypothesis was that the universe's fundamental basis isn't matter or energy or space-time, it's information. It's the immaterial logic that determines reality.
So the bit, the binary choice, the yes or no, that's the Atman or Brahman, the non-material logical choice.
It's the fundamental perfect signal. And the it, the physical object, the electron, the rock, is the secondary manifestation.
It's the Vikara.
The it arises from the processing of these bits. The physical world, in this view, is essentially a user interface. It's the output generated from some underlying cosmic chord.
And the bell curve, the fuzziness of probability.
Those aren't deep cosmic necessities. They are rendering artifacts. Or you could call them the resolution limits of the cosmic computation that's running the universe's software.
So the distribution isn't reality. It's a glitch in the simulation. A limitation imposed when you translate perfect code into a physical manifestation.
Exactly. And this resonates perfectly with a modern philosophy of science called ontic structural realism, or OSR.
And OSR moves away from classical realism, which insists on the reality of individual things.
Right. If traditional realism says an electron is a tiny real ball with definite properties.
What does OSR say it is?
OSR says that the thingness of the world is the illusion. It claims that only the mathematical structure, the relationships, the invariant equations that describe how things interact, only that is real.
Why prioritize the structure over the thing?
Because in quantum mechanics, the identity of a particle can be ambiguous. When you can no longer be sure of location or identity, the only thing that remains objective is the network of relationships. So the electron is just a convenient name we give to a set of mathematical relationships defined by the structure.
This is a radical affirmation of the whole inverted thesis. If reality is a mathematical structure, like Max Tegmark's mathematical universe hypothesis claims,
then any measurable deviation from that structure is literally a deviation from reality.
the residuals, the variance, the sigma squared we measure in our experiments,
They are the literal measure of how far our physical manifestation, clouded by Vikara, has strayed from the objective mathematical reality.
there's a similar cosmological framework that mirrors this Samkhya model in the work of the quantum physicist David Bohm.
Bohm's implicate and explicate orders.
That's right.
It's the perfect modern analogy for the signal-noise paradigm. The explicate order is the physical world we experience. It's the world of separate objects, space, time, and critically, the normal distribution. This is the world of the Vikara, the world of fragmentation generated by rajas.
And the implicate order is the signal, the unmanifest core reality.
The implicate order is a deeper holographic level of reality where everything is enfolded into everything else. It's a state of undivided wholeness where there is no separation, no distance, and fundamentally no chance or randomness.
So what we see is quantum randomness.
Bohm argued that what we observe as randomness, like quantum indeterminacy, is just the complex but deterministic variables of the implicate order manifesting imperfectly in the explicate order.
So that addresses the big question about quantum mechanics. If we see a bell curve in quantum results, it's not because the universe is intrinsically chaotic.
It's because the whole deterministic reality is being forced to manifest as fragmented parts. The bell curve is the statistical pattern the implicate order takes when it's forced through the dimensional screen of the explicate order. It is the necessary noise generated when an undivided, perfect reality is forced into the appearance of separation. It's the scar of fragmentation.
This entire framework rests on the idea of an invariant deterministic mean, the signal. In the Vedic tradition, that principle of constancy has a name.
It's called Raita.
Raita.
For Raita is the fundamental principle of cosmic order in the Rig Veda. It is the unvarying deterministic law that governs the path of the sun, the change of the seasons, all moral and physical conduct. Raita is the mean. It is the straight, intended path of the universe.
So if a Raita is a gravitational center, the mean, what's the opposition? What's the force that generates the variance, the distribution?
Opposed to Raita is Armta, which means disorder or falsehood, or Niriti, which means destruction. Armta is the variance. It's the wandering away from the prescribed path. It's the dispersive force of chaos and forgetfulness.
And the bell curve describes the permanent dynamic tension between these two forces.
The peak of the curve is Rada, the gravitational pull towards the law, towards truth. The tails are Armta, pulling things out toward dispersion and chaos. And this tension is played out perfectly in the laws of thermodynamics.
But the second law of thermodynamics, entropy always increases.
Which is simply the law of increasing Vikara.
As entropy increases, the signal spreads out, the distribution flattens, and the standard deviation sigma gets wider. The world is just getting noisier over time, moving toward maximal deviation.
Exactly. The universe began in a state of extremely low entropy, the perfect signal, a singularity. And as time progresses, the forces of Rajas push the system toward maximum entropy, which is the state of maximum Vikara.
And in a state of maximum entropy, the bell curve has completely flattened.
It's just a uniform distribution of pure, featureless chaos where all order, all information is lost.
Which means that life and intelligence are fundamentally anti-entropic activities. They are actively trying to reverse the statistical arrow of time.
They are the universe's attempt at nij-entropy. Science, statistics, spiritual practice, even evolution, they are all nij-entropic activities. They use energy and information to locally reduce variance.
To sharpen the curve.
They strive to sharpen the curve, to pull the observable world back into closer alignment with the underlying mathematical rule. To find the rule is to compress the data, to reduce the noise, and to return the system toward its low entropy source code.
And this is where the concept of dharma comes in, not just as a moral duty, but as a physical stabilizing mechanism.
Dharma is literally the force that upholds Raita. In the statistical model, Dharma acts as the universe's negative feedback loop. It's the error correction mechanism.
So when a system deviates from the mean,
That's adharma. And Dharma is the corrective pressure, the probability density that pulls the data points back toward the center. It counteracts the scattering force of Rajas.
so the very fact that we see a symmetrical bell curve, a structure, rather than just a flat, uniform distribution of chaos,
Is proof that Raita, upheld by Dharma, is actively fighting back against the relentless increase of entropy of Armta. The bell curve is the visible, measurable pattern of the struggle between constant mathematical order and the messy entropic forces of matter.
And this struggle brings us to a really profound conclusion, the realization that three seemingly disparate disciplines share one single core unifying purpose.
The minimization of variance.
It's the unifying principle of reality mastery.
The scientist minimizes variance residuals, error, to find the natural law, the equation. The statistician minimizes variance standard deviation to find the true mean, mu.
And the yogi minimizes the variance of the mind, chitta vritti nirodha, the stilling of the mind's fluctuations, to find the true self, purusha.
All three disciplines are structurally identical quests to transcend the defective modification of the phenomenal world and get back to the singular, silent reality.
The flip is now complete. The conventional definition of reality tells us the measurable, variable, concrete world is real, and mathematical laws are just abstract descriptions of it.
The Vikara definition tells us that the mathematical laws are the only thing that is truly real, invariant, and eternal. The concrete variable world, the normal distribution, is a defective illusion. It's a noisy transmission of the perfect code generated by the material screen.
The normal distribution is the veil of Maya. It's symmetrical, it's mathematically pervasive, it's beautiful in its structure, but it is ultimately a screen obscuring the single deterministic point of truth, the purusha, that lies at its center.
Our deep dive today suggests that the goal is not to stare at the elegance of the curve itself, but to utilize its structure, this distribution of error, as a map, as a tool of filtration to look through the veil to the unity and the law that lies hidden beneath all that noise.
So a final thought for you to take away. If randomness is merely a measure of our ignorance, what parts of our current scientific models that rely fundamentally on intrinsic stochasticity, from quantum indeterminacy to chaotic systems, what parts of those models will one day collapse?
When we achieve the omniscience required to measure the true deterministic rule of the implicate order, what ultimate unified reality awaits us when we finally minimize all Vikara?
The question is whether the universe's true code contains probability as a fundamental feature, or whether the bell curve will eventually be understood as the largest, most pervasive instance, the mind projection fallacy.
Thank you for joining us for this deep dive into the architecture of reality and the nature of defect.